Hello everyone, this is Mrs. Lindsay Pereira. Today we're starting the first day of section 1.6 about different types of pairs of angles. Now this is from the student journal, however you're going to see some examples are not in the journal, so you might need another piece of paper or right on the back. You could squeeze it in your journal as well. So the student journal will be used for the second part of it as well, so kind of again a little bit from the journal, a little bit that won't be in the journal. But today we're going to talk about complementary and supplementary angles. Okay, so the definition of complementary angles, in this case here, it's when you have two positive angles who sum up to 90 degrees. Okay, so they can either be adjacent angles, that means next to, or they can be non-adjacent. Either way, if you add those two up, whatever the two angles are, they must add up to 90. So if you're talking about supplementary angles, same sort of idea. We have adjacent angles and we have non-adjacent. What changes is with this is that they sum to 180 degrees. So two angles add up to 180 degrees, and again, they do need to be positive angles. Okay, so let's take a look at this, and these are not in your student journal. Okay, so find the complement of the angles below. So if I have 54 degrees here, to find the complement, so again this means sums to 90 degrees. Complement sums to 90 degrees. So to find the complement, this angle, the complement would be 90 degrees minus 54. So in that case, we would get that to be 36. So over here, same idea, the complementary angle, we would do 90 minus 35, and in this case, that will give us 55. 55. And again, we don't even need a diagram. So number 12 here is simply just 90 minus 12. So that's going to give us 78. Again, not in the student journal, but now we're switching gears. So supplementary, so this one sums to 180 degrees. So the supplementary angle to 100, again, you take 180 and you subtract it from 100. That gives you 80 degrees. And that's the same process we're going to do for all these. So if this is supplementary angle, you do the 180 minus the 36, and that will give you your supplementary angle, 144 here. And again, you don't even need a picture sometimes. So in this case, they just give you an angle of 146. So we get that to be 180 minus 146. So that's going to give us 34 degrees. So that means 34 plus 146 adds up to 180. Okay? Alright, so now we're going back to our student journal, so you can flip back to that. And it talks about naming some complementary angles. Now they start using the terminology here, adjacent complementary. So adjacent means, again, next to. So the two angles are next to each other. Okay, and complementary, again, so now we're thinking these two angles add up to 90 degrees. So name the pairs of angles that are adjacent. So this right here, 105, already over 90 degrees. So we're going to switch over here to this diagram. This means this angle is 90 degrees. So again, we need two angles because they're pairs of angles. So we're looking here at this 75 and 15. 75 and 15, yes, they absolutely do add up to 90 degrees. So we have angle, and again, this needs to be the vertex O, so it'd be angle SOT and angle TOP. Those are our complementary angles. And again, they are next to each other. Okay, so there are an example of non-adjacent complementary angles, but it didn't ask for the non-adjacent ones. And number 2, it asked for the non-adjacent. So again, these are not next to each other, and these are supplementary. So now we're thinking 180 degrees with this one. So these two are next to each other, so that wouldn't be applying to the non-adjacent. So let's look at maybe 105 over here and 75. That adds up to 180, but again, they're next to each other. So how about this 105 and this 75? So that would be angle LJM and angle TOS. So 105 and 75. But we have another 75 angle, and that's right over here. So 105 and this 75 would also be. So this is the exact same angle, so angle LJM and angle QOR. So 75 and 105 add up to 180. So we're good to go on those. Okay, so again, and they're not next to each other. Okay. Let's take a look at number 3 and 4. Find the angle measure. So it says complementary. A and B are complementary, and angle 36. Angle A is 36 degrees. So again, complementary means 90 degrees. So if I know A and B are complementary, and I know what A is, if I take angle B, if I do 90 minus 36, that will give me the measure of it, because again, I know they're complementary. So if I take 90 minus that 36, that again is going to give me 55. So angle B would be 55 degrees. So 55 plus 36 should add up to, oh no, I'm so sorry, 54. You say that would not be, 54 would add up to 90. Okay, so now supplementary. Again, we're thinking 180 degrees. So C is supplementary with D. We know D is 117, so again, to find angle C, we'd take 180 minus this 117, and that, excuse me, would give us our supplementary angle of 63 degrees. And again, you can always check your answers here. Take the 63 and the 117. If they add up to 180, you should be good to go with that. Okay. So again, you don't always need diagrams with these. It's okay to draw diagrams, but in this case, we can just simply subtract from either 90 or 180 degrees, depending upon if it's complementary or supplementary. Okay, so now let's take a look at 5 and 6. Okay, so there's an important detail about 5 here. So if I highlight this angle here, this larger angle, angle BAD, I have a very important marking here. That was provided in my diagram. So we know that angle BAD is 90 degrees. So that means this angle here, BAC, and angle CAD are complementary. So this plus this have to equal 90 degrees. So we can set up an equation from our diagram. So again, angle BAC plus angle CAD must equal that right angle. Now we've got a nice little equation we can solve here. Combine like terms, the 7x and the 10x. Then we have 22 plus 34, so that's going to give us 56. I'm going to subtract 56 from both sides. So 17x equals, that's going to be what? I believe 34. Yes, and then divide by 17, which should give us 2. Okay, so now this doesn't mean this is the answer to our question. just because we find out what x is, we need to go back and read our question. Is it looking for just x? No, it says find the measure of each angle. Okay, so we know angle BAD is 90 degrees. That's our largest angle in yellow there. Then we have this smaller angle here. So this is angle BAC right here. And so we need to actually plug in. We got a value of x for that to be 2. So if we plug that in, so let me go ahead and erase that. So I'd get this to be 10 times 2 plus 22. So that's 20 plus 22. So this angle here, BAC, would be 42. Now we have a couple different directions we can go. We could just simply plug in for CAD. We could simply plug in x like we did over here. So we'd have 2 times 7 plus 34. So that's going to be 14 plus 34, which would give us 48. Now, as a check, I'm just going to come over here. These two, yes, they add to 90. If they don't add to 90, we have done something wrong with this problem, because these two angles make this larger angle that's a right angle there. Okay? So then, on number 6, we have no markings. We don't have a right angle marked. But there's certain things we can assume from diagrams, and we're actually going to talk about that next. One thing we can assume from diagrams are straight angles. And straight angles are 180 degrees. So EFG is a straight angle. And therefore, we know that angle EFH plus angle HFG are going to add up to 180. So they're supplementary. So 6x minus 5 plus 12x plus 5 would equal 180. So now I got another little equation to solve. So 6x and 12x, so that gives me 18x. The 5's cancel off. If I divide by 18, I get x to be 10. And just like we did over here in 5, we're trying to find the measure of each angle. Well, we know angle EFG is the straight angle. That's 180 degrees. But we also need to find each of these individually. So if I'm looking for angle EFH, if I plug 10 in for that x, so it'd be 6 times 10 minus 5. So that's going to be 60 minus 5. So that gives us 55. And we could do the same for angle HFG. So 12 times 10 plus 5. And you're welcome to use your calculator, plug that in. So that's going to be 120 plus 5. So that's going to give us 125 there. And again, there's a quick little check here. I'm going to add those two together. Yes, that does equal 180. So we should be good to go with those. Okay. All right, so now we're going to kind of address what I talked about at the beginning here of 6. I said we can assume things from angles, and we can assume straight angles. Here is a diagram. Again, this is not in your journal, so if you need another piece of paper, you might want to pause, or again, flip it on the back if you've printed out the student journal. What can we assume from diagrams and what can't we? Okay, so I'm going to go ahead and show this to you. And you might want to pause the video for a minute. Go ahead and write this down. And then I'll talk about it once you guys get that written down. Okay, so what can we assume? Straight angles, again, we kind of talked about that in our previous problem. Since straight angles are lines, we can assume things are collinear. And since betweenness is based on being collinear, we can assume betweenness. Things we cannot assume. Right angles. Now I'm going to go back to our previous problem. The only reason we could say, and I'm going to take an eraser here, that this is a right angle is because it was already marked in the diagram. If this little box was not there, we cannot assume right angles there. Okay? You cannot ever assume an angle is a right angle, acute angle, obtuse angle. Nothing like that. You can't assume the relative size of it unless you know other information about it. And you cannot assume congruency, so congruent segments or angles. So even though this angle, I'm going to point out an example why. So even though angle A, let me highlight it here, ABC, even though that looks like a right angle, this measure could be 89 degrees, which is acute. It could be 90 degrees, which is a right angle. It could be 91 degrees, which is obtuse. So again, even though it looks it, we can't assume that. The only time we can know if it's a right angle is if it has the mark in there. So again, what can we assume? Straight angles, collinear, and between this. So we can assume E is between A and C because we know that this is a straight line and a straight angle. Okay? E is between D and B because again, we can assume straight angle, collinear, therefore between this. Okay? We can't assume anything about this angle, for example. BEC, we don't know it's acute. It looks acute, but we cannot make that assumption. Okay? So let's try to answer a couple of these questions here. Again, I apologize, this is not your student journal, so if you need some time to write this down, please do so. And let me move this over so you guys can actually see that diagram a little bit better. There you go. Okay. So pause if you need to. Okay. And we're going to use the diagram for these following questions here. Can you assume angle H&R is obtuse? And again, you cannot make any assumptions about relative sizes, so no. Name a linear pair. What is a linear pair is the first question. A linear pair is supplementary angles. So a pair of supplementary angles is really what it's looking for. That's the exact same thing. So you could say something like, I'm going to just pick out a straight angle here, a straight line, straight angle, same thing really. So I'm choosing S and R. So I could use angle H and S. So H and S and H and R. Now there are several answers for this one. Several. I can see 5 or 6 of them right now. So that's not the only answer to that problem. Okay. All right. So we're going to skip a couple problems. C is one of them because we're actually going to talk about that in the second day of notes. But we're going to jump down to D. Okay, so name a pair of adjacent. So again, that means supplementary. So adjacent supplementary angles. So adjacent means next to. Again, I'm going to pick out a different straight angle than the one with the linear pair. So I'm going to pick out H and K as my angle. That's a straight angle. So adjacent supplementary. So I'm going to say angle, let's just do, I don't know, angle H N E. Angle H and E, and then I'm also going to do an angle 2. So again, there's a lot of answers for this one as well. Okay, so really this question and this question are asking the exact same thing. Linear pair are supplementary angles that are adjacent. Okay, and I did say we're going to skip another problem. We are actually going to skip E right now. E we'll talk about. It's got a combination of what we're doing today and then a combination of what we did in day 2. Okay. So this concludes our notes, though, on the first day of 1-6.